All right, Gio, we got a blast from the past, sort of. Back in Unit 4 when we were proving triangles were congruent. We had the side, angle, angle, side, hypotenuse, leg theorem. This unit, sort of similar. Weird, we're using that word similar. Along the same path, but a little different, all right? So with proving two triangles are similar, we don't have to go through that whole process of show all three sides are proportional and all three angle pairs are congruent. We can trim it down to if you can show two angles of one are congruent to two angles of the other, similar. We could show that, remember side, angle, side, we got that angle is included in between the two sides. So we have to have the pair of angles congruent and the two pairs of sides are proportional. So we're not congruent. We got to set up ratios and show them that they're equal. Or side, where all three sides of one triangle are proportional to the other three. And so what we're going to do is we're just going to go through, I thought I cleared all these out, I'm sorry. We're going to go through and see which one each of these are. And if they're overlapping like this, I highly suggest you draw them right next to each other. Not really drawing to scale, trying my best to go fast yet. All right, so are these two similar? Well, what do we know? We have 82 degrees and 82 degrees. That was the given. And here's the trick. Both of these are x and x. So they have angles that are congruent. How many angle pairs? We got one angle pair, two angle pairs. So yes, these triangles are congruent using AA. And then we would say triangle XYZ is similar, that's the symbol for similar, is similar to X goes with X, Y goes with V, and Z goes with W. So that's just a simple AA. This one's a little bit trickier. We do have vertical angles. So we have the vertical angle theorem we could use for vertical angles. And we also have parallel lines. So parallel lines cut by a transversal, alternate interior angles are congruent, right? Where do we have alternate interior angles on this diagram? Well, here are our parallel lines, and then we have our alternate interior angles. So if they have parallel lines, we're going to say this angle is congruent to this angle, alternate interior angle theorem. Now we have two pairs of angles congruent, AA. The two angles were the vertical angles and the alternate interior angles. One could argue that K and G are alternate interior angles, and that is correct as well. So we would have a triangle KJH is similar to triangle GFH. That's our AA. Now let's go side, angle, side. It looks like side, angle, side, but we have to show proportional. So we have our angles. 120 is congruent to 120. 4 goes with 6. And then LN is 6. That goes with QR, which is 9. Reduce your fraction down. If the math is easy, I like to just do cross products quick. 36. 6 times 6, 9 times 4 is 36. You're showing proportional. So they are similar using side, angle, side. Triangle PQR is similar to triangle MLN. And again, gotta show proportional. So we have forget to hold down the small triangle LMK or KLM, however you want to look at it. That's 6 and 10. That's L, K, and M. And then we got ELJ, which the whole distance from L to E is 9. Add 6 and 3. Whole distance of L to J is 15. And we have angle L is congruent to angle L. So could be side, angle side, 9 to 6. All right. Left side to left side. Is that proportional to right side to right side? And again, you can do cross products. 6 times 15 is 90. 9 times 10 is 90. You can reduce that fraction down, divide it out in the calculator. They should equal the same number. And then last but not least, excuse me, looking to see what we have going on here. So we're going to pick out the small side. Corresponds with the small side here. So 21 to 7. Is that the same thing as 30 is to 12? And is that the same thing as 45 is to 15? Well, 21 divided by 7 is 3. 30 divided by 12 is not quite 3. So 2 point something. 45 divided by 15 is 3. Are they proportional when they don't equal the same thing? No. So the triangles are not similar. Corresponding sides aren't proportional. So you have to check all 3, not just 2. And then so again, we have this piece to the whole thing of 88. Well, they didn't give us that piece. 88 minus 56 looks like it's going to be 32. So we would have to say 32 to the whole 88. Is that the same as 44 is to 121? And is that the same as, and then 91 minus 43 looks like it's going to be 52 is this length here. Is that the same as 52 over 143? And then you could divide them out. If they equal the same thing, then we can say they're proportional, which is side, side, side. LKM is similar to LDE. So that is the 3. We're not doing 5 or anything. That is the 3.